Hey guys, Mr. Backward here. In this video, we're going to look at distance from a changing velocity. Now, distance is pretty easy to calculate if we're dealing with a constant or even an average velocity over a given time. But if that velocity is changing, things get a little bit more difficult. So let's think back to Galileo rolling his ball down a ramp. Now, as this ball is traveling down the ramp, it starts off rolling pretty slow, but as it gets further down the ramp, it starts traveling faster. And let's say, for the sake of this example, the velocity is going to be 2 times the time that the ball has been rolling down the ramp. And we're going to measure this velocity in feet per second. So for example, at a time of 1 second, if we plugged 1 in for our t value, the velocity of this ball would be 2 feet per second. Or if we wanted to look at a time of 2 seconds, if we plug 2 in for t, the velocity of our ball at 2 seconds would be 4 feet per second. And at 3 seconds, we could plug 3 in for t, and our ball is traveling at a velocity of 6 feet per second. Now let's say we wanted to figure out how far this ball actually traveled over those first 3 seconds. Now, if we think about our distance equals rate times time formula, but we're going to think about it in more of a calculus sense, we called the distance, we called that delta s. I'm going to leave the rate as r, and instead of time, I'm going to go delta t. Now, like we've talked about before, instantaneous velocity occurs at a specific instant of time. So in that case, our delta t value is 0 because we're looking at one specific freeze frame of time. And if I plug 0 in for this delta t, taking any rate times 0 is going to result in a delta s, a distance of 0. So if no time is elapsing, if we're trying to look at one specific instant in time, this ball is traveling 0 distance. It's not moving at all. Now, this example is very much related to that instantaneous velocity that we talked about back in 11.1. And like we said back then, typical algebraic techniques aren't enough for us to be able to calculate this. And the people who were studying this and working with this noticed those tangent line problems, finding a line tangent to a graph, and realized that the distance traveled type of problems were somehow related to it. But as they dug a little deeper, they didn't think about it so much as those tangent lines, but instead they thought about it as area. So that's kind of where we're going with this 11.2 stuff, starting to look at some area types of problems. That's going to be it for this video. Thanks for watching.